Today we'll be looking at calculus. So what is calculus? So for you to understand calculus, you need to have a basic understanding about straight lines, how to find the gradient of a straight line. You remember, because that's what calculus is all about. So like the case 1 here, the gradient of a straight line, you know that you use that formula. Not so. Remember this? This is what we find, or we use to find the gradient. Using 2 points, maybe any point along this line. If you remember the video which I had shared recently. Now when it comes to calculus, they tell you to find the gradient at a given point on the curve. Like for instance, at this point, what is the gradient at this point? At this point, because the difference is that when it comes to a straight line, a linear, you find that the gradient is the same throughout, but for the curve, the gradient at each particular point is different. No wonder we draw tangents at that particular point. So for you to find the gradient at each particular point, you need to do what? Use calculus. So for instance, I'm finding the gradient at this point. I'll draw a tangent. So meaning that this will have a general equation for the gradient. So that if I use this point, it will give me the gradient at this point. So this is now where it comes in, the differentiation method. That's what it means also, dy dx. So when they tell you find dy dx or differentiation, it's one and the same. In other words, you're finding the gradient of that curve altogether. That's how it is. Then in the integration, it's just the opposite of what? Differentiation. So if it's more like something that already differentiated, now you're taking it back the way it was. So that's just a basic understanding about calculus. So you find that at this point, gradient will be different from this point, at each and every point. But for this line, the gradient is one and the same. But it's not even that important. But it is important. So you just need to know how to find. So like for instance, this worked example, I saying that differentiate the following, or find dy dx. So like this is a curve, you see, the curve. So what's the general equation for the gradient of the curve, so that whatever you start you putting in numbers then to give you a gradient at each particular point. So how you go about is this. So have you seen why? So this is how you write the equation. So this is a general equation which you use. Where does this come from? For instance, this, you remember these things? Then here a, it's a coefficient, so this is what it means. So you multiply the power with the coefficient, then you subtract. In other words, if you don't mind, if it looks complex, just go by this method. So we just say dy dx will be equals to this times that number. What coefficient is this? It is 1. So 3 times 1, it is 3. Then you write that x, then you reduce it by 1, this one. So this will be 2. This is how you go about. Then this, then 2 times 2, it will be 4. Then you reduce it by 1, which will be power 1. So don't even write anything. Then there, then this one, it is power 1. All together, this is power 1. Then it will be 4. Then here it is 1 minus 1. Then to be 0. So x power 0, it is what? 1. So no wonder 1 times 4, it is 4. Then plus here, look at this one, it doesn't have x, so it's more like it is x power 0. Also, because the number power 0, it is 1. So no wonder 0 times 7 is 0. So no wonder we don't write anything. So in other way, this number, we don't write anything when it comes to this number. So we just end on those values which have what? X. So with practice, it will start making sense. So moving to the other one. Same with this one. So this times this, it will be 9. Then you reduce this by 1, which is 2. Then this one to be just 2. Then there it is 1. It is 0. 1 minus 1 is 0. Like that. So in other words, if a number doesn't have power, more than a power which is not greater than 2, meaning that just remove the x. That's how it goes about. Then it will just remain that number. So when it comes to this one, same. This by that, it will be 12. You reduce it by 1. There's x, then you reduce it by 1, it will be 2. Then this one doesn't have an x, so it is 0. So you end here. This is how you go about. So for instance, if here they told you that when x is equals to 2, what's the gradient at this point? There. if x was equals to 2. So upon finding whatever gradient is that, you just replace where there's x with a 2. That's how it goes about. So but all I want is to understand this. This is what you need to know about the first part about calculus. So the next time we meet, I explain to you the opposite, what you go about with calculus.